Hi everyone, today we'll be looking at the January 2020 P1 paper. Question 1, we need to find in its simplest form this integral, and I will start by writing it in a form that allows integration to take place. So it's 8x cubed over 3 minus a half x to the minus a half minus 5 dx. So we increase the power by 1 and we divide by the new power, minus a half x to the a half over a half minus 5x plus c. Do not forget the constant of integration. I need to simplify. The 8 with the 4 leaves me a 2, and the half with the half go away. So this is giving me 2 over 3 x to the power of 4 minus x to the half minus 5x plus c. In question 2, given that y is 3 to the x, we need to express each of the following in terms of y. We need to give each expression in its simplest form. We start with 3 to the 3x, which can be thought of as 3 to the x and all raised to the power of 3. I'm using the rules of indices here, whereby if I've got a power to a power, I multiply the powers together. So this is simply y to the power of 3. In B, we've got 1 over 3 to the x minus 2. I will start by splitting the denominator into 3 to the x times 3 to the minus 2. Now this is 3 squared over 3 to the x, which is 9 over y. And C, it's 81 over 9 to the 2 minus 3x, which can be written as 81 over 3 squared to the 2 minus 3x. I just wrote 9 as 3 to the power of 2. This is 81 over 3 to the power of 4 times 3 to the minus 6x. We multiply the powers together. 2 times 2 is 4, and 2 times minus 3x is minus 6x. So this is 81 over 3 to the power of 4 is 81, and 3 to the minus 6x is just 3 to the 6x. So this is 3 to the 6x, which can be thought of as 3 to the x to the power of 6. So this is just y to the power of 6. In question 3, we've got a part of the curve with equation y is x squared plus 3x minus 2. We've got the point P here, 3,16, lying on the curve, and we need to find the gradient. So I'm just gonna differentiate. The y dx is just 2x plus 3, and I will be evaluating this at x is 3 to find the gradient of the tangent. So it's 2 times 3 plus 3, which is 6 plus 3, which is 9. And therefore, the gradient of the tangent is 9. Now the point Q with x coordinate 3 plus h also lies on the curve, and we need to find in terms of h the gradient of the line PQ. So if I go back on the diagram here, there is another point here, it's Q. Its x coordinate is 3 plus h, and if I join these together, I could find the gradient of the chord PQ. So I will start by finding the y value when x is 3 plus h. So when x is 3 plus h, y will be 3 plus h all squared plus 3 times 3 plus h minus 2. So I'm replacing x with 3 plus h. I will expand this. It's giving me 9 plus 6h plus h squared plus 9 plus 3h minus 2, which is h squared plus 9h plus 16. And I could therefore say that the gradient of PQ which is rise over run. It's y2 h squared plus 9h plus 16 minus y1, which is 16, over x2, which is 3 plus h, minus x1, which is 3. Now, in the denominator, obviously, I'm left with an h, and in the numerator, the 16 goes away, and I'm left with h squared plus 9h, which simplifies to h plus 9. So this is, in terms of h, the gradient of the line PQ. Part C, explain briefly the relationship between the answer to B and the answer to A. Well, we just need to say that as h tends to 0, the gradient of PQ, which was h plus 9, will tend to 9, which is the gradient of the tangent. So what is actually happening here, if we go back on the curve here, is that as Q goes progressively towards P, that's what h tending to 0 is actually doing, then the gradient of the chord here will match the gradient of the tangent exactly at that point. Question 4, we've got a figure of the plan view of a house A, B, C, D and the loan A, P, C, D, A. Now A, B, C, D is a rectangle and we're being told that AB is 16 centimeters. Let me add this information here. Now we've got a sector of a circle, radius 12 meters. So this is 12 meters here. This is also 12 meters. So this immediately means that this must be 4 meters. So it's meters actually, so it's 16 meters. Now we need to start off by showing that AOD, this angle here, is 1.231 radians to 3 decimal places. So we start off by saying that cos of AOD is adjacent over hypotenuse, which is 4 over 12. This means that AOD turns out to be 1.230959, which rounds to 1.231 to 3D piece as required. Now, because the question was asking you to show that this is 1.231, you should show a more accurate answer which rounds to the printed answer. Now, the loan APCDA is shown shaded, and we need to find the area of the loan. So the idea is to find the area of the sector here, and then just deduct the area of the triangle here. I will start off by adding the information we've just established to be true here. This is 1.231. This means that this angle here, all of this here, is pi plus 1.231. And I will start off by reminding you that the area of a sector is given by a half r squared theta, provided theta is measured in radians. So the idea is quite simple here. I will find the area of the sector using the formula we just mentioned, and then I'm gonna deduct the area of this triangle, bearing in mind we've got this, and the included angle. So I'll be using a half AB sine C for this one. So the area will be a half. We know that the radius is 12, so it's going to be 12 squared here. The angle is pi plus 1.23095 ... minus a half AB sine C, so it's 12 times 4 times sine of 1.23095. I'm using full accuracy throughout, and I get an answer of 292.196, which is 292.2 square meters to 1 decimal place. Part C, find the perimeter of the loan in meters to 1 decimal place. So the perimeter will be the length of the arc plus the straight line part here and the straight line part here. So I will start off by finding AD, this one here, which is just Pythagoras theorem. So AD will be 12 squared minus 4 squared square root, and this is equal to 8 root 2. We know that the length of the arc is just r theta, provided theta is in radians, and therefore the perimeter will simply be the length of the arc, which is 12 the radius times theta pi plus 1.23095 plus the 8 root 2 we just found plus the 16, and this is giving an answer of 79.8 meters to 1 decimal place. In question 5, part A, we need to use algebra to find all solutions of the equation shown here. I will start by factoring out 10x, and I'm left with 2x squared minus 5x minus 3. I will further factorize this into 10x brackets 2x plus 1x minus 3, and therefore there's a total of 3 solutions. Either x is 0, or 2x plus 1 is 0, or x minus 3 is 0, which leads to x is 0, or x is minus a half, or x is 3. Now B, hence find all real solutions of this equation here. We need to realize here that x has become y plus 3 to the half. So this is the connection between A and B. So x is y plus 3 to the half, which is the root of y plus 3. Now we know that the square root will always be positive. So we have that the root of y plus 3 is 0, or the root of y plus 3 is minus a half, or the root of y plus 3 is 3. Now if the root of y plus 3 is 0, it simply means that y plus 3 must be 0, and therefore y is negative 3. For the root of y plus 3 being minus a half, this is not possible, so we reject this, not valid, because we said the square root will always be a non-negative answer. And root of y plus 3 is 3, means that y plus 3 is 3 squared, y plus 3 is 9, so y is 6. So the two solutions are negative 3 and 6. In question 6, we have the line L1 with equation of 3x minus 4y plus 20 is 0. We've got the line L2 cutting the x-axis at the point 8, 0, parallel to L1. We need to find the equation of L2. Now, to find the equation of L2, I need to inherit the gradient of L1 since the two lines are parallel. So for L1, we had 3x minus 4y plus 20 is 0. So I will start by making y the subject of this formula. 3x plus 20 is equal to 4y. So 3 over 4x plus 20 over 4 is equal to y. And therefore the gradient of L1 is 3 over 4. And this is equal to the gradient of L2 because the two lines are parallel. Now, to find the equation of L2, I will be using y minus y1 is mx minus x1. So y minus 0 is 3/4 x minus 8, using the fact that we pass to the point 8, 0. I will cross multiply to get 4y is 3x minus 24, and then collect everything on the left hand side. 4y minus 3x plus 24 is 0, in order to match the 4 in which I had to give my answer to. Now the line L1 cuts the x-axis at P and the y-axis at Q. Given that PQRS is a parallelogram, find the area of PQRS. I will actually start by finding the coordinates of P and Q. So we know that the equation was 3x minus 4y plus 20 is 0. Now at P, it's a cut on the x-axis, so y is 0, and therefore 3x plus 20 is 0, which means that x is minus 20 over 3. And at Q, the cut on the y-axis, x is 0, and therefore minus 4y plus 20 is 0, leading to 20 is for y, so 5 is equal to y. So I've got the two cuts on the axis for the line L1. So I will actually try to produce a sketch to illustrate all of this. So these are my axes here. I will draw first of all the line L1, for which we've got the cuts on the axis. So this is Q, this is P. Now Q was 5 here, P was minus 20 over 3. Now this is L1, and we've got the line L2, which is parallel. We also know that this line passes through 8, 0, so it could be something like this. So this is L2, this is 8, and this is P, Q, R, and I will create a parallelogram. Now this is the parallelogram here, so PQ is parallel to RS, and PS is parallel to RQ, and we need to find the area of this parallelogram. I think it makes sense to find the area of this triangle here and then just double it in order to find the area of the parallelogram. So this is what we have here. Now it's easy to see here that the base of this triangle is 8 plus 20 over 3, and the height is 5. So I could simply say that the area of the parallelogram will be 2 times the base times the height over 2. Plug this on your calculator and you are getting an answer of 220 over 3 squared units. And then part C, we need to find the coordinates of S. Now, to find the coordinate of S, I will actually be using vectors. I will say that the route to go from Q to R is the same as the route to go from P to S. So to go from Q to R, I need to go 8 units to the right and then 5 units down. So this is 8 and this is 5. And it's exactly the same route that one needs to follow in order to go from P to S. So there it is. Which means that the x coordinate of S will be minus 20 over 3 plus 8, which is 4 over 3. And the y coordinate will simply be negative 5, and therefore the coordinates of S are 4 over 3, comma, minus 5. You might notice that the sketch here suggests that the x coordinate of S is negative. However, you need to bear in mind that this was not accurately drawn, and therefore this is the correct answer. This was just for illustration purposes. In question 7, we've got the graph of 3 sine x. X is measured in degrees. Point P is point Q lie on C1, and we need to state the coordinates of P. Well, I will actually start by considering what kind of transformation is 3 sine x. So y is 3 sine x is a stretch along the vertical scale factor 3, which means that all the y values are multiplied by 3. We know that the original graph of sine x has a maximum point at 91, so 90,1. And if I multiply the y values by 3, it's going to be 90,3. These are the coordinates of P. And then for the coordinates of Q, well, Q is this point here. We know that the sine x hits the x-axis every 180 degrees. So this is 180, 360, 540. The y coordinate was 0, so it's not affected by this transformation. So Q has coordinate 540,0. Now a different curve, C2, has equation y is 3 sine x plus k, k is a constant. This curve C2 has a maximum y value of 10, and the point that is the minimum point on C2 with the smallest positive x coordinate, and we need to find the coordinates of R. So I will start by considering y is 3 sine x plus k. Now I've got the graph of sine x. 3 sine x means multiply y by 3. And then the plus k means then add k. Which means that in the original graph of sine x, we had a 90,1. So if the y value gets multiplied by 3 and then we add k, it's gonna be 90,3 plus k. And we know that this graph has a maximum at 10, which means that 3 plus k must be 10, and therefore k must be 7. So we were told to find the coordinates of R, where R was a minimum point on C2. Now, a minimum point in the original sine wave is at 270, minus 1. So what we will do is we will be multiplying y by negative 3 and then adding 7. So it's going to be minus 1 times 3 plus 7, which is 270,4. These are the coordinates of point R. In question 8, it's a straight line y is k brackets 2x minus 1 and the curve y is x squared plus 2x plus 11. And we need to find the set of values of k for which L does not cross or touch C. I will start by equating the two. I've got x squared plus 2x plus 11 is equal to k brackets 2x minus 1. I will be expanding the right hand side and then collecting everything on the left. So we've got x squared plus 2x minus 2kx plus 11 plus k is 0. So I will write as x squared plus 2 minus 2k brackets x plus 11 plus k is equal to 0. So the discriminant has to be negative because the line and C do not cross, they do not touch, so the discriminant has to be negative. So we want b squared, 2 minus 2k all squared, minus 4ac to be less than 0. I will expand this. It's giving me 4 minus 8k plus 4k squared minus 44 minus 4k less than 0, which gives me 4k squared minus 12k minus 40 is less than 0. I will actually divide everything by 4 to make the numbers smaller. K squared minus 3k minus 10 less than 0. This factorizes into k minus 5, k plus 2. And of course, we've got critical values of 5 and -2. I will quickly draw a smiley parabola to see the critical values and decide the region I want. So this is -2, this is 5. It goes plus, minus, plus. We want to be less than 0, so we want to be in between the -2 and the 5. So my answer is -2, less than k, less than 5. In question 9, we need to find the x-coordinate of the point on the curve at which dy dx is 0. We need to show all stages of the working, and solutions relying on calculus or technology are not acceptable. In order for me to find an expression for dy dx, I first need to write it in a form that allows differentiation to take place easily. So it's 4x squared over 2x to the half plus 9 over 2x to the half, which is 2x to the 3 over 2 plus 9 over 2x to the minus a half. This means that dy dx is 2 times 3 over 2 x to the half plus 9 over 2 times minus a half x to the minus 3 over 2. I will simplify this into 3x to the half minus 9 over 4 x to the minus 3 over 2, and we need to set this equal to 0. So 3x to the half is equal to 9 over 4 x to the minus 3 over 2. So 12x to the half, I've cross multiplied, is 9 over x to the 3 over 2, which means that 12x squared is 9, crossing multiplying by x to the 3 over 2. So x squared is 9 over 12, which is 3 over 4, which means that x is the square root of 3 over 4. I'm not putting a plus minus because x is greater than 0, so this is just root 3 over 2 since x was greater than 0. In question 10, we are told that f of x is 4x minus 3 times x minus 5 all squared, and we need to sketch this curve showing the coordinates of any point where we touch or cross the coordinate axis. Now if we expand this, we see that it's a cubic with a positive x cubed coefficient, which means that the shape will be like this. Now we also know that when x is 0, to find the cut on the y-axis, we see that y is 0 minus 3 brackets 0 minus 5 all squared, which is minus 75. So we are cutting the y-axis at negative 75. When y is 0, we have that 4x minus 3 is 0, or x minus 5 is 0. So either x is 3 over 4 or x is 5, and this is actually a double root. And this is enough information for us to proceed with the sketch. So we draw the y-axis and the x-axis, and we've got a first cut on the y-axis at negative 75, and then we've got cuts at 3/4 on the x-axis and 5, and it's a double cut. So the shape agrees with what we had originally. So f of x is 4x minus 3 brackets x minus 5 squared. That was part A. In part B, it says hence or otherwise find the values of x for which f of a quarter x is 0. So we will start by considering the transformation corresponding to f of a quarter x. So this is a stretch along the horizontal, scale factor of 4. So this essentially means that all the x values get multiplied by 4. So solving f of x is 0 means look at the cuts on the x-axis. So now we want to consider what the cuts on the x-axis will become. So the 3/4, 0 will become 3, 0 because x got multiplied by 4, and the 5, 0 goes to 20, 0. So the solutions are x is 3 and x is 20. And then in II, find the value of the constant p such that the curve with equation y is f of x plus p will pass through the origin. Now, f of x plus p is a translation p units up, so it means that this graph here will move like this. So let me write this down. Y is f of x plus p, translation p units up. We want the new curve to pass through the origin, so it's obvious that it should go 75 units up, so that the cut on the y-axis, which was at negative 75, is now at 0, and therefore p is 75. C, we've got a second curve, y is g of x, such that g of x is f of x plus 1. We need to find in its simplest form g of x, and we may leave our answer in a factorized form. So g of x is f of x plus 1, which means we replace x with x plus 1. So it's 4 brackets x plus 1 minus 3 times x minus 1 minus 5 all squared. So the x plus 1 is what replaced x, and this leads to 4x plus 4 minus 3 brackets x minus 4 all squared, which is 4x plus 1 brackets x minus 4 all squared. And it's okay to leave it like that because we were told it's okay to leave it in a factorized form. And then the II part, hence or otherwise find the y-intercept of the curve, where the y-intercept simply means that the x must be 0. So when x is 0, we get that the g of 0 is 0 plus 1 brackets 0 minus 4 all squared, which is 16. And therefore the point through which we cut the y-axis is 0, 16. In 11, we've got the curve with equation y is f of x, and we're being told that the second derivative is this. In addition, we are told that the point P with coordinates 4, minus 50 lies on the curve, and the gradient at this point is negative 4. We need to find the equation of the normal at P, giving our answer in the form y cos mx plus c. So we know that the gradient of the tangent is negative 4, and therefore the gradient of the normal should be a quarter. We flip and we change the sign. We know that we pass through 4 negative 50, so y minus y1 is mx minus x1. And we've got y minus minus 50 is a quarter x minus 4. So y plus 50 is a quarter x minus 1, which leads to y is a quarter x minus 51. That's the equation of the normal at P. In part B, for 8 marks, we need to find f of x. Well, I will start with f dash dash of x, which is 6 over x to the 3 over 2 plus x. I will write this as 6x to the minus 3 over 2 plus x. I will integrate once to go to f dash of x. So it's going to be 6x to the minus a half over minus a half plus x squared over 2 plus c. which is minus 12x to the minus a half plus x squared over 2 plus c. I'm gonna use the fact that f dash of 4 is negative 4 because at the point P with x coordinate 4, the gradient of the tangent was negative 4. I will substitute this into the expression we just obtained to find the value of the constant c. So this is minus 4 is negative 12 times 4 to the minus a half plus 4 squared over 2 plus c, which leads to minus 4 is 2 plus c, so negative 6 is c. So f dash of x is minus 12x to the minus a half plus x squared over 2 minus 6. Now I'm gonna repeat essentially the same process once more to go from f dash to f. So f of x will be the integral of minus 12x to the minus a half plus x squared over 2 minus 6 dx, which gives me minus 12x to the half over a half plus a half x cubed over 3 minus 6x plus c, which is minus 24x to the half plus a 6x cubed minus 6x plus c. And I will now use the fact that f of 4 is minus 50, the coordinates of P, to substitute and find the value of the new constant c. So negative 50 is minus 24 times 4 to the half plus a 6 times 4 cubed minus 6 times 4 plus c, which leads to minus 50 is equal to minus 184 over 3 plus c, and therefore 34 over 3 is equal to c. And I only have to write that f of x is minus 24x to the half plus a 6x cubed minus 6x plus 34 over 3 to complete my answer.